Assalamualaikum and hi everyone. Today we are going to learn subtopic 4.2 double integrals over rectangular region. Okay, over rectangular region. So if you refer to the module, you may turn to page 226. Page 226. So as usual, I already prepared some slides for you. So let's take a look at this slide. Alright, subtopic 4.2 double integral over rectangular region. Okay, so actually we can calculate volume under a surface by using double integration. Alright, so in this case, we have the double integration towards region R. Okay, this is the region. So you have to bear in mind that region R must be taken from the limit. Okay, and this double integration with respect to dA is actually, we can have dy dx or dx dy. And fxy is actually our z, okay, the surface. So according to Fabini's theorem, double integration over rectangular region is divided by two types of double integrals. Okay, so we will have type 1. This is type 1, dy dx first. Okay, we will integrate with respect to y followed by x, and then type 2 is dx dy. So we integrate with respect to x first followed by dy. Okay guys, since this double integration is over rectangular region, means all of the limits, x is from a until b and y is from c until d, all of the limits are constants. Okay, rectangular region means all limits are constants. Therefore, both of these types of integrals, either type 1 or type 2, will give you the same answer. Okay, only for the case of rectangular region, but for the case of non-rectangular region, the result will be different. Okay, so for rectangular region, it's up to you whether you want to use type 1 or type 2. Both will give you the same answer, so you don't have to worry. Okay, I will solve this. So let us open this example 1. Okay, we have integration from -1 until 1. From 1 until 4, we have xy to the squared plus 4y dy dx. Okay, so let me teach you how do we sketch the region, the rectangular region. Alright, in this case, we have limit of y. Okay, limit of y. Y is from 1 until 4. And then we also have limit of x. X is from -1 until 1. So now, this is our region R. So let us sketch the region R. So this is x-axis and y-axis. So we have x from -1 until 1. So from -1 until 1, and then y is from 1 until 4. Until 4, okay? So we will have this region, 1 until 1, negative 1 until 1, and then 4, okay, 1 until 4. So now, yes, we have this region, right? The rectangular region. So this is our region R. Okay. So let us solve this question. Negative 1 until 1. Okay, so I rewrite again the equation here. Xy squared plus 4y dy dx. Okay, so first of all, we need to integrate with respect to y. So in this case, x becomes the constant. Alright, I repeat. If we want to integrate with respect to y, thus x becomes a constant. So what you should get here is, from negative 1 until 1, integrate xy squared with respect to y, we will have xy cubed over 3 plus integrate 4y with respect to y, we will get 4y squared over 2. Okay, close this. So we substitute the limit. Here we have y equals to 1 and then y equals to 4, so dx. Okay, so let us substitute each variable y with the limit. Therefore, we have negative 1 until 1. Substitute y equals to 4 first. So we will have x multiplied by 4 cubed over 3 plus 4 divided by 2, so 4 over 2 multiplied by y squared, so 4 squared, like this. Okay, minus. Substitute y equals to 1, so we have x over 3. Substitute y squared equals to 1, so we have 4 over 2 dx. Okay guys, also if we solve this, we will get from negative 1 until 1, 4 cubed is 64, so we will have 64 over 3x plus 64 over 2 minus x over 3, and then minus plus becomes minus. 4 over 2 is 2 dx. So we will have equals to, from negative 1 until 1, so 64 over 3x minus x over 3 becomes 63 over 3x. So plus 64 over 2 should be 32. 32 minus 2 becomes 30. So plus 30 dx. So we can now integrate this one, equals to 63x over 3 becomes 63 over 3x squared over 2 plus 30x. Substitute x equals to negative 1 and x equals to 1. So finally we will get 63 over 3 times, okay, x substitute with 1, so we have 63 over 6 plus 30, and then minus negative 1 squared, so becomes remain positive. We have 63 over 6, and then plus 30 times negative 1 minus 30. So the answer is, alright, so this one we can cancel here, so 30 plus minus minus become plus, therefore the answer is 60. That's it. Okay, let us proceed to the second question, second example. Okay, evaluate example 2. integration from 0 until 1, and then from 0 until 3 to exponent to the power of 4x plus 2y dx dy. Okay, now first of all, let's take a look at our region R. So region R is according to the limit here, region R. So we have, if I resketch region R, we have, okay guys, now we have limit of x here is from 0 until 3. So x is from 0 until 3, and then limit of y is from 0 until 1. So if we sketch the region, the rectangular region, we will have something looks like this. So everything is positive. All right. X equals to 0 here, and then x equals to 3 here. And then y equals to 0, y equals to 1. So now this is the rectangular region. Okay, so let me shade the region. So here, this is the region. Okay. Let us solve this question. Equals to from 0 until 1, 0 until 3 to exponent 4x plus 2y dx dy. Okay, in this case, we integrate with respect to x first. So when we integrate with respect to x, thus y becomes the constant. So we will have 0 until 1, integrate with respect to x, we will have, take out the coefficient, so we have 2, integrate exponent to the power of 4x. So exponent to the power of 4x, we have, first of all, you just remain the power of exponent. So we have exponent 4x plus 2y. Now 4 is the coefficient here, so we need to get, we need to divide this exponent over 4. 2y just remain because 2y now are just a constant, okay? 2y just a constant. So we just copy it down here. Now you can substitute the limit since we integrate with respect to x. So limit of x equals to 0, substitute x equals to 3 dy. Okay, now we will have 0 until 1. Okay, now we can cancel this is 1, here is 2. So we have 1 over 2, take out 1 over 2. Substitute x equals to 3, so exponent 4 times 3 is 12, plus 2y minus, substitute x equals to 0, we have exponent 0 plus 2y, so exponent 2y dy. Now we have, take out 1 over 2 because it's just a constant, so integrate exponent 12 plus 2y, so we will have exponent 12 plus 2y. So now the coefficient of y is 2. What we should do here is we divide by 2. Okay, so now minus exponent 2y divided by 2. So substitute y equals to 0 and y equals to 1. Finally, we will have 1 over 2. Substitute y equals to 1, we have exponent 12 plus 2 times 1, we get 14 over 2. Minus exponent 2 times 1 becomes exponent 2 over 2. And then minus exponent 12 plus 0, so exponent 12 over 2. Minus exponent 0, exponent 0 is equivalent to 1, so 1 over 2. Like this. Okay, so since all of the denominator equals to 2, so 1 over 2 times 1 over 2, we will get 1 over 4. So we have exponent 14 minus exponent 2 minus exponent 12 plus 1 over 2. That's it. So this is the answer. Okay, now let's take a look at example 3. Okay, this is example 3. We have integration involving the trigonometric function. So let us solve this question. Okay, example 3. Integration from pi over 2 until pi, and then we have 0 until pi over 2 of 2 sine 2x minus 3 cos 3y dx dy. Okay. Now the region R, we have here x, so x is from 0 until pi over 2, and then y is from pi over 2 until pi. So if we sketch the region, we can have a rectangular region like this. So x is from 0 until pi over 2, so this is pi over 2, and then y is from 0 and y is from pi over 2, so let's say this is pi over 2, and then y equals to pi somewhere here. Okay, so now your graph would be like this. So let us shade the region. Wait a minute. Oops. Okay. So this is your region R. We can proceed with the integration now. From pi over 2 until pi. Sorry, this is 0. Okay, now again, integrate with respect to x here. So integrate with respect to x, y becomes the constant. Okay, x the variable and y becomes the constant. So we will have integration from pi over 2 until pi. Okay, integrate 2 sine 2x. Integrate 2 sine 2x, we will get negative 2 cos 2x over 2. Okay, and then now integrate negative 3 cos 3y. Negative cos 3y means the whole thing becomes the constant because there are no x here. Okay, so since all of these are just a constant, integrate constant with respect to x, we will get the constant multiplied by x. Thus, we can get negative 3 cos 3y multiplied by x, or we can write the answer like this, negative 3x cos 3y. Substitute x equals to 0, x equals to pi over 2 dy. Okay, so let us substitute the limit. Now we have from pi over 2 until pi, negative 2 cos 2x, x substitute with pi over 2, so we will get, okay, first we can cancel this. So we have negative cos 2 times pi over 2 should be cos pi, minus 3 pi over 2 cos 3y. Okay, minus, substitute x equals to 0, we will have negative cos 0 minus 3 times 0. So 3 times 0 is 0 dy. Okay, now cos pi is equivalent to negative 1. Cos 0 is 1. So we will get from pi over 2 until pi, negative 1, so becomes positive 1, minus 3 pi over 2 cos 3y, minus negative 1 minus 0 dy. So we will have equals to pi over 2 pi, 1 minus minus 1, so becomes 2, minus 3 pi over 2 cos 3y dy. Okay, so now integrate 2 with respect to y, we will get 2y. Integrate negative 3 pi over 2 cos 3y, equivalent to negative 3 pi over 2, just a constant. So integrate cos 3y, we will get sine 3y over 3. Substitute the limit of y equals to pi over 2 and y equals to pi. So we will have 2 times pi minus 3 pi over 2 sine 3 pi over 3, and then minus 2 times pi over 2, so becomes pi minus 3 pi over 2 sine 3 pi over 2 over 3, like this. So we will have, okay, sine 3 pi is 0, sine 3 pi over 2 is actually negative 1. Therefore, we will have 2 pi minus 0 minus pi negative 3 pi over 2 times negative 1 over 3, like this. So we get 2 pi minus pi, negative plus and negative again. So we have minus plus, so minus pi over 2, so pi minus pi over 2 becomes pi over 2. That's it, done. Okay, now let's take a look at example 4. Okay, example 4, we have these types of function. So let us solve this one. Integration from 0 until 2, 1 until 4, x square root of 9 minus x squared dy dx. Okay, so for this type of function, we need to use substitution. Okay, but first of all, we integrate this with respect to y first. So when we integrate this with respect to y, x becomes a constant. Okay, so the whole thing is just a constant because with respect to y, so just constant. Therefore, we will have 0 until 2. Since just a constant, so we can take this out. So x 9 minus x squared, integrate constant with respect to y, we get the constant multiplied by y, right? So we have y here. So substitute y equals to 1, y equals to 4 dx. Okay, so we will have 0 until 2, x 9 minus x squared, so 4 minus 1 dx. So we have 3. Okay, so 3 times 0 until 2. So x 9 minus x squared dx. Okay, now we need to use substitution. Okay, use substitution. We let u equals to 9 minus x squared. So differentiate u, differentiate 9 we get 0, differentiate negative x squared we will get negative 2x dx. So now from here we can have dx equals to du over negative 2x. Okay, now actually it's up to you whether you want to use the original limit. So you need to substitute the original limit later, or if you want to substitute the limit now, then you can change the limit. Alright, let me change the limit. So when x equals to 2, u equals to 9 minus 2 squared, because previously we know that u equals to 9 minus x squared. So x equals to 2, therefore 9 minus 2 squared, we get 5. Okay, and then when x equals to 0, we have u equals to 9 minus 0, so we get 9. Okay, now what we can do here is we substitute here 3. Okay, so 3. Okay guys, so now we can substitute the limit. When x equals to 2, u equals to 5. So we have 5 here. And then when x equals to 0, u equals to 9. So the limit here should be 9. And then we have x. Okay, square root of 9 minus x squared. Okay, 9 minus x squared is actually u. Okay, 9 minus x squared is u. Okay, so we have we need to substitute u here. So u square root of means to the power of half. Okay, so u to the power of half. Alright, dx. Dx is equivalent to du over negative 2x. Okay, now we can cancel this x and this x. Okay, so therefore the integration would be turned like this. 9 until 5 u to the power of half du. Okay, the negative 1 over 2, you can put it in the front here, negative 1 over 2. Okay, so now we can integrate this easily. Alright, negative 3 over 2 can be taken out. So negative 3 over 2, integrate u to the power of half, u to the power of half plus 1. So 3 over 2 over 3 over 2, right? So substitute 9 and 5. So if we rewrite the denominator, it can be rewritten as this one. So 2 over 3, u to the power of 3 over 2, 9, 5. So we can cancel the value here. Sorry. We have this. Sorry, my pen is not functioning. Okay, we can cancel. Okay, now, thank God. All right, we can cancel these 2 and these 3. So we will have, wait a minute, negative u to the power of 3 over 2. So substitute u equals to 5 minus 9 to the power of 3 over 2. Therefore, we will get negative 5 to the power of 3 over 2 minus become plus 9 to the power of 3 over 2 equivalent to 27. Yes, so the answer is 27 minus 5 to the power of 3 over 2. That's it. Done. Okay, next, the last example. Example 5. Okay, let's take a look at example 5. Use a double integral to find the volume of the solid under the plane z equals to x plus y over the rectangular region. X is from 0 until 4, and then y is from 2 until 6. So if you notice in my first slide, okay, we have the formula of volume like this, right? So formula of volume equals to double integration towards region R, and then we have fxy dA. Okay, so let us solve this equation. So volume, it said that first of all we need to let z equals to fxy. Okay, and we know that region, okay, so the volume is double integration towards region R, fxy dA. Okay, so we know that x is from 0 until 4, and then y is from 2 until 6. So therefore, the volume is equivalent to, okay, 0 until 4, that is for x, and then limit of y is 2 until 6, and then fxy. Okay, in this question we have z equals to x plus y, so we know that this is your z. So since z equals to x plus y, thus fxy equals to x plus y. So now we write the function of xy here, x plus y. So the first limit is with respect to x, so we have dx dy. Okay, so we can solve this integration equals to 2 until 6. Integrate x with respect to x, we will get x squared over 2 plus integrate y with respect to x, we get xy. Substitute x equals to 0, x equals to 4 dy. So now we have from 2 until 6. So 4 squared over 2 should be 8. 16 divided by 2 is 8, right? Plus 4 times y. So 4y minus x equals to 0. So 0 plus 0 dy. So we just need to integrate this one. 4y dy. So integrate 8 with respect to y, we will get 8y. Integrate 4y with respect to y, we will get 4y squared over 2. So substitute 2 and 6. So we will have 8 times 6 is 48. So that's 4 divided by 2. So 2 times 36, 72 minus 16 plus 8. So we have 120 minus 24. So the answer is 96. Alright, done. Okay, so we finished already all the examples. Right guys, so now you can try to do these exercises and the answer are already given. So all the best, good luck. That's all. Thank you very much.